So at this point, we will jump into the next presentation with Arnaud Buchholz. And Arnaud will be talking about a different approach to UI5 testing. So that will be, testing is a very important part of application development, and one that is often sort of left behind. And Arnaud has been working on those topics and has some really interesting approaches to share with us. So I'll hand it over to Arnaud at this point.
Yep, thank you. So this presentation is about a different way to test UI5 applications, and the agenda will be very short, but I will explain you that after. Quick words about myself. So I'm working at SAP for the last 6 years. I'm in the software industry for quite some time now, very experienced with JavaScript, and I like to try to think out of the box whenever I face a problem. So the agenda for this presentation would be that we will typically talk about the reason why I went into this consideration of building my own test runner. And then I will explain you all the steps I went through to build it. So hopefully at the end of this presentation, you will get a clear understanding of why this test runner was created and how it runs. Obviously, the main recommendation I have to give here is that the UI5 tooling is the recommended way to develop your solution. But as you know, the UI5 ecosystem is growing. So sometimes innovation requires to ignore the recommendation and try other paths in order to develop new stuff. And that's exactly what the presentation is about. So to put you in the context of why I started this new tool, I would like to rewind a little bit and send you back to 2018, where I would say everything started. So in 2018, I gave a presentation to UI5Con, which was a journey with OPA, where I explained how you can use OPA to test your applications. The year after, I gave another presentation where I explained how you could use UI5 to test your OData service by embedding UI5 inside the Node.js command line and automate the execution of the test through an OData service. The year after, last year, COVID occurred, and I didn't went to UI5Con, but with a colleague of mine, we wrote a book called Testing UI5 Application, which more or less summarizes everything about OPA and qunit testing inside the applications. So I guess you get the main idea here. I have a strong quality focus, and I'm part of a team who is responsible of more than 10 applications. The official recommendation for this application is to have at least 80% of coverage, both backend and UI. This ends up having us developing huge test suites, and some of them can run for up to 45 minutes whenever we deliver something. And this year, we started to have some troubles with these test suites. In particular, the continuous integration pipeline started to fail with the Karma runner. And because I'm very familiar with OPA testing, actually my pyramid of tests is a little bit skewed. So my unit tests are very small, and usually my OPA tests are very big. And the point is that we use extensively the iframe mode when running the OPA test. So this generate already a huge memory consumption. But on top of that, when you execute the continuous integration pipeline, you want to extract the coverage information from this test, which adds up to the memory consumption. So we realized that inside the continuous integration pipeline, our tests were abruptly aborted. And after some further qualification, we realized that this was coming from a browser crash because of the memory consumption. And actually, we use Karma, and in the poll, I requested people to answer if you use Karma to run your test, and it looks like not all of you are using Karma, but at least some of you are. And there was another question, which is, do you know how Karma actually executes the test? And that's something that I was really curious to understand, to try to figure out how I can split the test in order to improve this memory thing. And the problem is that I have no clue how Karma is running the test. So the Karma UI5 plugin, I looked into it, but I don't know how it works. So based on this very simple assumption, I started to think about a different solution. But before going to this solution, I somehow analyzed what was happening within Karma. So when you run your test with Karma, what happens is that all the tests are being executed in only one window. And on top of that, this window is composed of an iframe where the tests are executed inside this iframe. So if you add to that the fact that we have OPA iframe, it means that we have iframe within iframes, which from a memory consumption point of view is a disaster. On top of that, all these tests are executed sequentially inside the same window. And obviously, because we want to extract the coverage information, this is also executed during this test. So this is what we have with Karma. And in order to illustrate that very quickly, I will share my screen and show you one execution of Karma on the sample application that I developed for 2018. So here it is. So you should see my screen. I will simply run Karma here. And while it's running, I would like to show you several things. So I have to grab the window when it opens. Here it is. There we go. And at the same time, I will also open this task manager to show you the memory consumption of Karma. So the thing is, as you can see, all my tests are executed inside the same window. And since I'm using OPA with the iframe mode, this window also contains an OPA frame. And as you can see inside the task runner, the memory consumption is going up very high, very fast. Obviously, after some time, when the tests are over, this memory will come down because JavaScript is using garbage collecting. But the problem is that if your browser is stressed for 45 minutes executing lots of different tests, this memory doesn't have the time to go down. And this is the reason why in the continuous integration pipeline of the test I was talking about, 45 minutes, after some point, it reaches 2 gigabytes and the browser simply crashes. So that's the thing I wanted to somehow solve. So coming back to the slides here, I would like to discuss first, how do we serve UI5 application? So you all know that when you develop a UI5 application, the very first thing to do is to bootstrap UI5. And this is done by loading the SAP UI-core.js, which usually is referred inside your project with no specific version, but the path is always relative to the project and under a resources folder. So on the slide, you've got the example here. And from there, all the dependencies of your project will be loaded either under resources for the libraries on SAP UI5 or test resources for everything related to the test. If you use a development environment such as WebIDE, in order to run your application, the mapping with this resources SAP UI core is done through the neoapp.json, which means inside WebIDE, you have a fast way to select which version of UI5 you want to run, and this is somehow encapsulated by the IDE. So this is pretty convenient. You have no installation required, but it's quite hard to automate. On the other hand, if you use UI5 CLI, then you have this possibility to install all the UI5 packages locally, which means that you are self-sufficient and you can run your application and you can even automate it. That's the way Karma is running this test. But the problem is that whenever you want to switch the version that you want to use, then it's a little bit more complicated. So that's why I talk about the fastidious version switch here. On the other hand, you still have the option within this bootstrap tag where you load the UI core.js, you can load it from a UI5 content delivery network, which means by adding an absolute URL, which points to a very specific version of UI5, then everything will be loaded from there. And for the rest of the files of your application, you just need a web server to deliver the files so that they can access UI5 and your data service over the HTTP protocol, because obviously you cannot load it with the file protocol. It wouldn't work. So this kind of setup is pretty light because from an installation point of view, you get all the resources from the CDN. But the problem is that to automate the version selection, you need somehow to modify the file that you run in order to switch the version that you're using. So the question you would have here is, can we combine a lightweight setup with the fast and external version selection in an that can be easily automated? And this is where I would present you the first project here, which is called Reserve. Reserve is a very small web server, less than 60 kilobytes, written in JavaScript using Node.js. And it allows to develop very quickly a web server that has very convenient features to deliver a UI5 application, for instance. So on the screen here, you can see that with a simple JSON, like the one written on the slide, you have two mappings. One of the two will match every incoming request looking like a resources or test resources access to a UI5 resource. And it will redirect this request directly from the CDN in order to serve this request. On the other hand, if the resource is not, or if the request doesn't request a resource or test resource, then everything else will be served from the file system. So in order to show you what it will do, I will share my screen again. And I will this time start very simply this JSON file you've seen. So this is the one I will be using. And in order to start the web server, I just have to start Reserve. It will pick this reserve.json. And from then, automatically, I can start my browser pointing to localhost, and then the application is served almost immediately. So that's one easy way to deliver the files and make the application runnable. We are not yet able to test the application, but at least we can serve it. So from there, how can we build a test platform? So first of all, in order to build a test platform, we will need options. So when I started this project, I considered that every time I had to make a choice in terms of which UI5 version you want to run, where is the web app folder, which port do you want to use, I put everything inside options. So this makes the whole test platform very configurable and very easy to reuse. So just to show you very quickly, these are the list of options you have access to. So all of them are documented, and I will show most of them today, but don't worry, it will be explained. Then, in order to serve the application, so the application that we want to test needs to be served in order to execute inside the browser. So the same way, we will use Reserve, but this time it will be embedded inside the Node.js application. So as the same way you could use a JSON to configure Reserve to serve your application, you can programmatically do the same. And that is what is written on the slide here. You have very few instructions to reuse. And the mapping that you can see on the slide is exactly the same as the one you had inside the JSON file, but some parts are coming from a job variable, which represents the current job to execute. So it contains all the parameters you might want to consider. So the UI5 repository, the files, and things like that. But in order to test the application, we also need to execute it. So it means we need to spawn a browser that will run the application. So to do that, two commands will be created inside the test runner. That will be start and stop. Start will simply start a browser on a given URL, and stop will stop this browser, which means the browser will be stopped whenever the test platform will consider that it has to be stopped. And I will explain that after. In order to instantiate the browser, this feature will be deferred to an external script so that it can be reconfigured on using something else. But by default, I'm using Puppeteer, which is a mechanism that allows you to automate Chromium browser through Node.js. And here you have an example of the script that is being used, and you will see that there are two parts. On one hand, when the script is started, it will use Puppeteer to start the browser on the given URL, which is the process.argv2. But also, since this command line is spawned from the test runner, what happens is that there is a link between the two. And at any time, the test runner can post a message to this command line. And this is this mechanism that I use in order to tell the command line that it must stop the browser. So this is what you see at the top of the script here, process.on. Whenever it receives a message, it will stop the browser. The final command line contains more, but again, I will come on to that a little bit later. So when I started this prototype, because it started with a prototype, I first conducted some tests to validate that if I run several browsers at the same time on the same web server, they would not conflict together. So for instance, I validated that the timeouts are being managed properly. So you might know that if you open the browser tab and then this tab is no more active, the timeouts, so everything related to set timer or set interval, will no more be as granular as you specified. Luckily, with Puppeteer, even if the browser is not visible, the timers are still respecting the granularity that you specify. The same way, the local storage is really important. If your application is manipulating the local storage, for whatever the reason, you have to make sure that this manipulation does not interfere with another browser also manipulating the local storage. Luckily, Puppeteer separates those local storage when you instantiate more than one browser. Unfortunately, or the same way, the cache is also separated, which means if you load UI5 inside this Puppeteer browser, what happens is that it will require some time to cache all the files, which means that this cache is dropped when the Puppeteer Chromium browser is stopped, and the next time you open a new Puppeteer Chromium browser, it starts with a fresh cache, which means you need to download all the SAP UI5 resources again. Luckily, to compensate from that problem, the test runner also includes a caching mechanism so that this compensates from the problem of having the cache to be filled inside the browser. Now that we have a way to start a browser on a given page, now that we have the way to serve the application and execute this page, we need somehow to collect information from the test execution. So remember, this test platform that we are building will also be a web server. So because of that, what will be done on top of serving the application files, serving UI5, it will also expose endpoints to receive feedback from the executed test pages. And I will explain how it works later. But the same way, since you have several browsers that may work at the same time, you need to uniquely identify which browser is sending information to the test runner. And this is done using the current URL of the browser. Since each test page will have a different URL, whenever this browser posts the messages to the test runner, the header of this request will contain the referrer information, and this referrer information contains the URL of the browser that is sending the message. So using this referrer information, we can easily distinguish which browser is submitting what information to the test runner. So that was one elegant way to enable multiple execution. So let me show you this running of the application using the platform. So what I will do, I will start UI5 test runner, but this time I will specify a parameter parallel just to prevent the execution of the test as of now. So it's a little bit of teasing, and I will specify the port to make sure that the port that is allocated is the right one. So if I start this, I can refresh the browser here, and it still serves the application the right way. So from a serving point of view, everything is correct. And for the rest, don't worry, you will see that right after. So we have a test platform. We can start browsers. We can collect information from the test pages. Now we need to know, what do we run? Which tests are actually ready to be executed in your application? So this is where the probing step occurs. In UI5, whenever you develop an application, the recommendation is also to develop a test suite page. This test suite will refer all these sub-test pages that are contained in your project. So usually what you put in this test suite, you have the QUnit test page and the OPA test page. And everything is well documented. And I remember seeing in the templates we've seen previously, they are already created with some of the templates of the Yeoman generator. So this test suite page, whenever you open it, there is a redirection that occurs, and this is what happened here. And then you move to the UI5 web test runner that will execute all your tests. So this is exactly what happened in my browser here. But what if we take the opportunity to replace this QUnit test runner to collect the information about the test pages and send them back to the test platform? So when you declare the test suite page, this is what you see on the slide right now. You have typically one script that is being included that is coming from UI5, which is called qunit-redirect. And this page does whatever it has to do so that at some point, the suite function that you see on the slide here will be executed in a context where it gets a unit test suite object on which you add some test pages. So what if we took this opportunity to replace qunit-redirect with something else so that we keep the same interface, but instead of redirecting to this qunit page, we collect the test pages to execute. Now that is what is done by the test runner. We substitute qunit-redirect.js with a custom strict, and then what we do, we capture all the list of pages that we want to execute. So this is how the script is working. That's what you see on the slide, but actually I will show you it directly in the live demo. So what I will do here, I will rerun the test runner, but this time I will use a different setting, parallel -1. It's a hidden setting, don't look for it, but that's one that will just do the necessary step to extract the test pages. And as you can see here, those pages are extracted from the test suite. If you see the test suite, test suite here, this is generated by this code here. But what is interesting is the fact that if you look now, this qunit-redirect file, which is delivered by the platform. So this is the one I have in the cache of my browser. But if I refresh it, oh, this one has changed. So it's no more the one being delivered by UI5, but this is the one delivered by the platform, which collects information about the different test pages that were added and send them back to the platform using this endpoint, add test pages. So we have the way to execute a browser. We have the way to serve the application, and we now have the test pages. So we just need to execute them. But when we execute them, we need to control what happens during this execution. So this is typically where we will leverage qunit inside the test execution. You obviously know that qunit tests are based on qunit, but you may know also that OPA tests are also based on qunit, which means the OPA framework is built on top of qunit. So everything is built on top of qunit. And qunit offers hooks to monitor the test execution. So you have qunit begin, test done, and done. And they provide not only information about the progress of the test execution, but also about the status of the test execution so that you can know if anything went wrong or if everything is correct. So what we will do based on that is that whenever these qunit modules are being loaded by the application that is being run to execute the test, we will, on top of the qunit source, which is coming from UI5, inject some hooks in order to trigger some calls to the test platform whenever a test is successful. So just to show you that, I will go back to my list of links here. So if I open the qunit.js version 1, but also the same for qunit version 2, you can see this is the qunit files. So right now they're coming from the cache of the last execution of the application. But if I refresh it, you will see that at the end, now I have this injected qunit hooks that will communicate with the test platform whenever a test starts, it's completed, and so on. So that's a quite elegant trick. So now we have everything in place to execute the test, but also monitor the test execution. So what we have left to do is to schedule the different test execution. So what happens is that we will start as many test pages as specified by the parameters, knowing that by default, the parallel parameters enables two parallel execution of browsers. So this gave me some headaches to implement it in JavaScript, but in the end, it's pretty simple. And this is what you see on the slide right now. It's a simple loop on the number of parallel execution that are allowed. And I trigger this run test page asynchronous function. So it's using extensively promises so that I will start a browser and I will wait for the browser to complete. And the test platform will take care of stopping the browser either because we got the qunit done callback saying that it's okay, the test is over, or because there is a timeout setting that allows you to shut down the test if it goes over, let's say, 15 minutes. Once that is done, the function recalls recursively itself so that it goes to the next test. And if there are no more test page to execute, then it will stop. And the last one to stop will conclude the loop of the test pages by generating a report. So let's make the final demo, enough of the teasing. So what I will do, I will start UI5, not in this window, hopefully. So I will stop this one. I will run UI5 test runner using two parallel execution. I will specify the port so that I will show you one page that allows me to monitor the execution. I will enable the cache to make sure that it goes faster. And I will also use keep alive so that we can continue using the web server after the test execution is done. Once I do that, I will also start a page, which is a hidden page inside the test runner that allows you to monitor the progress of the execution of the different test pages. So it's not obvious here, but you will have to trust me on that one. These executions are done in parallel. And you can see those blue lines growing up. They are the consequence of listening on the qunit hooks to know how many tests are being executed per page and when they are being executed. And once everything is executed successfully, as a result, you get a report here that shows you for each test page how many of them failed. So here everything is perfect, but obviously that's not enough. You might want also to see a report out of this test execution. So the command line also provides a report which shows you all the results of the test execution. So here it's easy because everything is greenish, but if you have any problem, it will also report on the problem and show you the stack of the session that failed. I modified the command line also to capture a screenshot of the test execution, as well as capturing the console log outputs from the test execution. So obviously, from a debugging experience, if you face any trouble, you should have enough information from there to start with. So that's about executing the test in parallel. But we're still missing one thing to be fully compliant with what Karma is doing. That is the code coverage measurement. So to measure the code coverage, I actually have to explain you what it means measuring the code coverage. So the process requires 3 different steps. The first steps requires you to modify the source files in order to instrument them. Instrumenting the source files somehow add some additional code to your code so that whenever a function is being triggered or a condition is being tested, the additional code will keep track of where you went so that it can later report on if those lines were executed or not. Then, obviously, once the code is instrumented, you need to evaluate the code. So you need to execute the code that you instrumented, or not the original code. And last but not least, once everything is executed, you will extract from this test execution the coverage information and consolidate it in order to generate a report that makes sense. So in order to do that, I'm too lazy to implement it myself. So I use a tool called NYC. NYC is a command line wrapper for Istanbul. Istanbul is one of the most famous JavaScript code coverage tool. And the value of NYC is that with simple command lines, you can instrument the code and generate the code coverage reports. So since the platform test runner is already capable of spawning commands because of the browsers, so I just reuse the same mechanism and I spawn an NYC command line in order to instrument the code and do whatever needs to be done with code coverage. So instrumentation has to be done before executing the test, obviously. But the one challenge that I faced here is that by default, the instrumentation of the code generated by the instrumentation aggregates the code coverage information at the global object level, which inside the browser means the window. The problem is that since we're using extensively OPA iframe mode, it means that the window in which the code coverage information is collected is dropped at the end of the test execution because we shut down the application at the end of each journey. So in order to solve that problem, because this coverage information was lost, I modified a little bit the code coverage, the instrumented code coverage sources in order to change the scope of this coverage consolidation to put it at the top window instead of just the window, so that even once the journey shut down the application, I still have my coverage information within the window that executes the OPA test. The way it works from a serving point of view, so as I mentioned at the beginning, Reserve is pretty flexible. So what I do here, and that's what you see on the slide, is that I created a new mapping so that whenever an instrumented file exists for source files, it's being delivered first instead of the source file. But if the corresponding instrumented file doesn't exist, because for instance, by default, the test sources, you don't want to instrument them because you don't need the code coverage on the test files. So these ones will be served the normal way using the default handler that serves through the files. Something that is really interesting in this model is that each test page is executed separately, which means also that each code coverage information is consolidated individually. And I will come back on that later. But once everything is terminated, those unique coverage information coming from each test execution needs to be aggregated and then generate a report. And NYC provides a way to do that. There is a merge command that will aggregate all the coverage information, and there is a report command that will generate a report so that you can have a nice user-friendly report for the code coverage information. So I will not re-execute everything. I will simply share my screen again and show you the reporting that was generated. So here we go. Okay, hopefully you see my screen. So now I will go there and I will show you the report that is being generated. So this is a report generated out of the last execution. So as you can see, we have 100% coverage, and you can dig down to every simple component here. Something else I wanted to show you is the result of the instrumentation. If I open the component.js source file, which is part of the application, this is typically what you would see inside the source. This is the result of the instrumentation. But if I open, let's say, the mock server file of this application, this one is being part of the test mandatory files, which we don't really care about the coverage because it's not a productive file. So this is why this one appears as clear source and it's not instrumented. Let me go back to the slides. So let's conclude this presentation by recap everything I told you and hopefully convince you that this tool is really interesting. So the UI5 test runner. Let's rewind back to the Karma execution model. So Karma is a nice tool. I never said that it was not nice, but it's a generic tool that was adapted to UI5 with some plugin. Right now, the way it works, all the tests are executed in one window, and it's even worse, it's one iframe that executes all the test pages, and these pages might also contain iframes. The execution of these tests are sequential, so as a result, you have to wait for all the tests to execute uniquely. The coverage information is extracted out of the box. That's pretty cool. The only problem I have with Karma is that from an implementation point of view, it's quite obscure to me. And what I can see from the poll, it looks like at least most than half of you also don't have a clear understanding of what Karma is doing when executing the test. So if you compare it with UI5 test runner, UI5 test runner is something that I built especially for UI5. And because of that, it's, I would say, not necessarily optimized, but it understands how UI5 execute the test, and it leveraged this understanding to execute all test pages individually in distinct windows. So this enables parallel execution. And as I showed you, it also enables coverage information extraction. And hopefully, through this presentation, I gave you some explanation about how the implementation is working. Maybe I was a bit pretentious, but I hope that it gives you a crystal clear understanding of how the implementation is working. In any case, it's open sourced and you can access it. It's really not a big program. Yeah, anyway. Tips and tricks, and I will finish with that. If you want to benefit from the parallelization of the test execution, there is one really important tip I would like to share with you. That is, you have to split the OPA test into several pages. So one pattern that we use in my team that I can give you today for free is to simply consolidate all the journeys that you will execute inside one file. That's what we do in my team. So we have one file called, sorry, I need to share my screen again. So we have one file called alljourneys.json, which enumerates all the journeys that we want to execute. And then what we do is inside the test suite.qunit, we grab the file using an HTTP, an XML HTTP request, and then we enumerate each journey that we have it, and we add as a test page the OPA test suite page, but with a parameter that says journey is equal to. And what we do inside the OPA test unit.html, we do exactly the same thing. We grab the list of journeys, and if we have the parameter journey equal to, then we focus on loading only this journey. And if not, then we load all the journeys. And that's a way we can split the OPA test per journeys. So that was one tip I wanted to share with you. And the second one that I want to share with you is the fact that if you want to speed up the test execution, it's preferable to cache the UI5 resources locally. So this UI5 test runner offers the option to use the -cache option, which what it will do, it will also, once getting the UI5 resources from the CDN, it will store them locally. So that the next time the same resource is requested for, let's say, a different page, instead of fetching it from the CDN, it will serve it locally. So as a result, you gain quite a significant amount of time in terms of execution. I didn't stress out the time needed to execute the test with Karma, but it's almost 40 seconds. And using this test runner, we go down to 32 seconds. Not a big gap. But if you remember at the beginning of this presentation, I told you that the tests which were failing on the continuous integration pipeline were taking almost 45 minutes. And thanks to this new test runner that we put in place inside the pipeline, it now goes down to 25 minutes. And that's pretty cool. That saves a lot of time. Enough with the screen sharing. I will stop it. So let's quickly discuss about the future of this tool. So right now it's ready to be used. Maybe it lacks a bit of documentation, but I can complete that. But I'm also thinking about improving the tool in several ways. First of all, something that is not documented here, I implemented recently an option called fast fail. That sounds stupid, I know, but you know what? I don't like to have to wait 25 minutes if I have at least one test failing in my test, which means maybe the test fails after 2 minutes and I still have to wait the remaining 23 minutes before I can stop the Jenkins jobs, because I know that in any case I will have to resubmit something because the job failed. So the fast fail option will stop the test execution as soon as one test fails. It will terminate the journey that is failing, but the other ones won't be started because we know that in any case you have to do something with it. Also, I say that the different test execution generate this different coverage information. And I'm thinking about trying to implement a smarter watch, which means most of the tools that you have access to today, like Karma, allows you to have a watch mode so that whenever you modify a source files, the tests are evaluated in the background, and it gives you such as a real-time status of your test execution. But most of the time, it executes everything. But now that we have coverage information, which is split per test page, actually, based on the fact on the file that changed, I could deduce which test pages are impacted by the change, because I have coverage information by each test page. So it doesn't mean that we have to re-execute all the test suite. You can focus only on the one that you know that will be impacted by the file that you have changed. And that's something I would like to experiment to see how much it will save time regarding this watch mode. Also, something that could be interesting, if you want to use test grids, for instance, to test all the versions of browsers or whatsoever, I would need Selenium integration. So I would need to develop a small command line to browse, to instantiate a browser using Selenium. And that shouldn't be a big deal, easy to do. And that's it, right in time, hopefully. That's it for me.
Excellent. Thank you so much. That was a presentation that gave a lot of great ideas around building test harnesses and test coverage for UI5 applications. We have a couple of questions, and I think we've got a couple minutes to get into them. The first question was around what your thoughts are for integrating this into a CI/CD pipeline, like GitLab or another pipeline.
So I'm not an expert of pipelines, to make a long story short, but the point is this tool is a command line. So if you can trigger a command line inside your pipeline, you can integrate this tool in your pipeline. The only thing you have to do is first install it locally. So this is using npm install, -g if you want to install it globally or locally to your project if you want to. And then you just have to execute it with the right set of options. And then like any command line, it will generate a 0 return code if everything is successful, and something different from 0 if anything went wrong, so that you can easily automate the pipeline status based on the command line execution to say that it worked or it failed. So it should be possible, but I cannot tell you how. What I can tell you is that it has been integrated in our continuous integration pipeline.
Great. So definitely possible. Maybe as someone who has so much experience with writing and maintaining and running tests for UI5, can you talk a little bit about the amount of effort that's required to build these tests, and how you manage that with your teams?
You mean to build the tests themselves or the test runner?
The tests themselves. So the question was specifically, do we need 2 developers to build an application now, one to build the app and one to build the tests?
Okay. Yeah. Okay, so that's a very long question that deserves more than 3 minutes. But to make a long story short, I personally prefer having the developer developing the test, because most of the time, when you design the code, you design it such a way that you make it testable. So if you have separate developers, it might be quite complicated to synchronize on what you're testing, mostly for unit tests. When it comes to OPA test, it's easier because OPA is like component testing. So you're testing an application on its final look. So if you know that you will have a button, you just have to code the click on the button. But even then, I believe it's simpler to have the same developer doing not only the code, but also the test, because in terms of responsibility, I prefer to be involved in the testing part because I believe it's an important part of the job. I'm not sure I completely answered the question, but that's my answer.
I would agree with your answer. So yeah. thank you for going into that a little bit. Last question. So it looks like this framework could be used to run tests in multiple browsers. Have you tried that? Do you have a plan for that? I think you mentioned it with the Selenium test grid.
So right? Yeah. To be honest, I developed this tool in maybe 3 weeks. So I wanted to have a fast solution because we were stuck with our continuous integration pipeline. But that's why also I externalized everything that can be changed. And typically, the command line that is used to instantiate Puppeteer is really outside of the test runner. And you can easily override it using a parameter to trigger any command line you would like to. So you could, thanks to this mechanism, use a Selenium browser, so instantiate any Selenium. The only thing that you have to think about is that this test runner is self-sufficient, which means it also includes the web server. So if, for instance, you're using a test grid that is externalized from some partners or whatsoever, this partner needs to be able to contact the test runner web server, and that might be a challenge. So yeah.
Excellent. I think that's all the questions we have. Thank you so much, Arnaud, for going through that presentation. As I said, it brought a lot of thoughts to the forefront about things that we can all do to improve, I think.